Okay, hello everyone. Great to sort of be here. I guess I'm currently based in Massachusetts, where it's you can't see, but it's snowing. So too bad I can't be down there where I guess it's nice and sunny and never snows. Sounds nice. Um, so I don't know how many people are seeing this, so it's a little hard without the feedback, but I'll do what I can, and I'll talk about discrete log contracts today. Um, so these are privacy preserving smart contracts on Bitcoin. Cool. Quick intro. I'm Tadge Dryja. I work on Bitcoin research and developing at the Digital Currency Initiative at MIT, which has been around for 5-something years and employs some of the core developers. So there's a lead maintainer of Bitcoin Core and Corey Fields and other people. And we work on Bitcoin and have been for quite a number of years. So that's cool. Actually, my current work is called utreexo, which is a scalability solution for Bitcoin that allows Bitcoin full nodes to be much smaller in disk size. And so that's a cool project. Not what I'm going to talk about right now, but that's sort of my current project that I'm programming. And this, I'm talking about the discrete log contracts. So earlier, 5+ years ago, I wrote the Lightning Network paper, Joseph Boone. And so the discrete log contracts idea and network has a lot of similarities to Lightning Network. And so I think at this point, Lightning Network is much more well understood. So I don't have to explain all of that, but I also use Lightning Network terminology to describe discrete log contracts. Okay, so the basic idea of discrete log contracts and a lot of these smart contracts, right, is conditional payments. It's that simple, right? It's you want to pay someone conditional on some external data, something in the real world happening or something in the virtual world happening. So as an example, Alice and Bob want to bet on tomorrow's weather. So if it rains, Alice gets a Bitcoin. If it's sunny, Bob gets a Bitcoin. And they want to have a bet. That's a conditional payment. Another way to say it is bets. But yeah. So the one problem is the Bitcoin blockchain is not yet aware of the weather, right? There's no up weather to see you. And that's, you can't do that. And so you can use like smart contracts. And the idea of smart contracts, it's, a lot of people think Ethereum and stuff. But Bitcoin definitely supports smart contracts and has since the beginning, all the script stuff. So for example, Lightning Network, it's a simple script, but it is a smart contract, right? It's enforcing that the most recent transaction in a channel is the only one that can really be used. But what's interesting about Lightning Network is all the data is completely internal, right? There's, let's say Alice and Bob have a channel on the Lightning Network and they're sending, payments back and forth. There's no external data. There's nothing coming from outside their channel that affects their channel. So that's sort of nice and self-contained, right? There's no need for an oracle. If you want external state, though, if you want to say, okay, well, this payment is conditional on the price of oil, or this payment's conditional on the weather, or some interest rate, or some kind of thing, then you need some way to get that information in there, and we call that an oracle. And the simple ORAS tool would be multisig. So you can imagine using just 2 of 2 multisig for a kind of bet, where you say, okay, I bet it's going to rain, you bet it's going to be sunny. Let's just put our money in a 2 of 2 multisig, and then at the end of the day, we say, okay, it was sunny all day, cool, I win. But that's not really useful, right? It's okay with friends, maybe, right? Because if you just say 2 of 2, then you both have to agree. So the loser has to acknowledge their loss. And with friends, that sort of works and doesn't really scale. I guess as a topical example in America right now, there's an election, and there isn't a concession. So what that does is also puts rich players at advantage. They sort of wait it out. I didn't lose. Let's wait. It works great for friends, but Bitcoin is the currency of enemies. So you could also have like a 2 of 3 multisig oracle, where you say, okay, Alice and Bob are betting, and you have some third party that is not Alice and Bob who will sort of adjudicate, and in the case of conflict, they will decide who wins. That could work. Oh, sorry. I'll clip this in as maybe it's moving around. Sorry. Is that better? Hopefully it's not rubbing, hitting anything. Okay. So yeah, so 2 of 3 multisig oracle would also be possible. That also has issues. And so if you have 2 of 3, you say, okay, there's Alice, Bob, and Olivia. And Olivia is sort of the third party that determines. If Alice and Bob are chill, they can both sign without contacting Olivia. But if Alice and Bob are fighting and unresponsive and they don't agree on who won or who lost, Olivia can then sign as the second of 3. The obvious problem here is, let's say it's sunny, but Alice tells Olivia, hey, it's Alice, I lost, but if you say it's raining, I'll give you 0.8 of the Bitcoin, right? I know I've lost everything, but if we can collude, then you get some and I get some, and that's better for me. So right, collusion, third parties can be bribed. So 2 of 3 multisig oracles, and in fact, many of the oracles we see in like DeFi kind of stuff, they're interactive, right? They see every contract because they're on the blockchain. And not only do they see them, they decide the outcome of every contract individually, right? So like in Ethereum, you end up calling these oracles, and it's, returns a value. They can equivocate. The oracle can change what they're saying. So really it'd be better if the oracle couldn't equivocate and they had to sort of commit to a single value. And even better if the oracle never even saw which contracts they were using. So, but how do we do this? So I don't know if I should skim through this real quick. So Schnorr Signatures, if you're aware, they are really cool. They were the sort of original elliptic curve, the original digital signature, that especially for elliptic curves, but it was patented. So for 10, 20 years, we couldn't really use them, or no one wanted to use them. And now the patent's expired, so hey, we can use it again. The general equation is fairly straightforward, especially compared to ECDSA, where you have your public key, you have this generator point on the curve, your private key is just a random number, you multiply to get your public key, and then you do basically the exact same thing to get a nonce for a signature. A nonce is just a sort of one-time use private key, and then you multiply that by the generator the exact same way and get sort of another public key, this R point. And then the signature itself is that sort of one-time use public key and this S, which is K minus the hash of your message, and R times your private key. And then you can verify that sort of by multiplying both sides by G. And so what we have for DLC, we don't actually use Schnorr signatures, right? The equation is similar, but it does not need Schnorr signatures or Taproot in Bitcoin. It can potentially benefit a little bit, but it uses the regular ECDSA signatures that are in Bitcoin today. But it sort of the offline Oracle part does use a modified Schnorr signature, right? So you can use it today in Bitcoin, and there are companies using it today on Bitcoin without Taproot, without Schnorr. But sort of the offline portion does use something like Schnorr signatures. And so, yeah, like I've showed, the Schnorr signature, and similar, you sort of have a pub key you make, and then you make another public key basically for a single use, and then you compute S. What you do in DLC, you have a fixed R pub key. So normally in signatures, you say, okay, I'm going to make a public key, and I can use that many times. And then when I make a signature, I have this sort of one-time use public key and this, scalar S. We use the same equation, but we switch it to say, okay, in discrete log contracts, your public key is both A and R, and your signature is only S, right? So the equations are the same. It's just that instead of coming up with R at the time of signing, you come up with R beforehand, and you commit to it. So your public key is now twice as big, and your signature is now half the size, right? And this works. So it's the same thing, right? The equations are the same. It's just when you're doing this, right? And the reason, so to some extent, same idea, right? Okay, pub key's twice as big, signature's half the size, cool. You could use this in regular Bitcoin transactions or anywhere. The reason people don't is it's kind of worse in a big way. The thing that makes it worse is you can only now sign once, because you can only use R once. And I don't have to go through this whole thing, but if you use the same R more than once, you lose your private key. And this was like PlayStation 3 code signing was broken this way. There have been several, a good number of attacks in Bitcoin, with Bitcoin having, Bitcoin wallets having poor engineering where they use the same R. And if you use the same R twice, you lose. All your money's gone, your private key's revealed. But what that does in discrete log contract, it's actually got sort of two purposes. One, it forces the oracle to only sign once. So they say, okay, this is the public key I'm going to use to sign tomorrow's price of Bitcoin or something, or price of gold. And I can't sign twice, right? If I sign two different values, I say, oh, gold is worth 0.05 Bitcoins or whatever, or gold is worth 0.99 Bitcoins. If they sign twice, they lose their private key, and then everyone can sign everything. It's very obvious. It also has the important part that you can now compute, how do I put this, what signatures look like before the signature occurs. So you can sort of compute the one side of the signature. You can compute the signature times G before there's an actual signature. You can compute it from any message. And what that sort of does is let you say, okay, now I have like a public key of the signature, right? And now when the signature actually happens, I learn that private key. And then, so it's this kind of weird cryptographic trick where now for any message, the oracle says, okay, here's my public key. I'm going to sign something tomorrow, and I'll tell you what I'm going to sign. I'm going to sign the weather. I'm going to sign what the price of something is. And now before they do sign, we can anticipate their signature. We can say, okay, if they sign 5, it'll look like this. If they sign 6, it'll look like this. And we can use that version of their signature that we anticipate and throw that into Bitcoin transactions. So the way we do it is we sort of are using their signature as a private key that unlocks a possible transaction, right? So just to compare again, in Lightning, what we do is we set up a channel, right? You've got this fund transaction output. And you say, okay, there's 10 Bitcoins in here. And we sort of keep updating what transaction is now valid. So the first state is Alice has 1 coin, Bob has 9. And then Alice has 5 and Bob has 5. And then we destroy the Alice 1, 9, right? And then we go to the next state. Alice now has 9 and Bob has 1. And then we go back and destroy the 5 and 5. And the way we destroy it is we reveal private keys so that the other party can take all the money if we broadcast that. That's a justice transaction, I guess, in some code bases, or breach remedy transaction in others. And so we're using the same mechanism. So from an external perspective, if you're looking at the network, the discrete log contract looks exactly the same as Lightning. But what it is instead we build, let's say, all 3 possibilities ahead of time. So before we even open this channel, it's not a channel, but it looks like one. Before we open it, we say, okay, here are the 3 possible things that happen. And these are all at the same time. We're signing them. Say, okay, it might be sunny, it might be cloudy, or it might be rainy. And if it's cloudy, we split it. If it's sunny, Alice wins. And if it's rainy, Bob wins. And now the only thing that determines what's valid is the oracle then signs. And the oracle signs, okay, it was cloudy. And now this transaction can be broadcast. And these other 2 cannot because we have the extra key from this oracle to make this transaction possible. So that's really cool. It allows, and so from the blockchain perspective, you look at it, it looks like a Lightning Network channel. There's no way to tell the difference. And actually, if the 2 parties cooperate, you never even see this transaction, right? They can roll it over. You can also put discrete log contracts within Lightning channels, right? So you could say, okay, we've got our Lightning channel that we're using, and one of the outputs of this channel is a discrete log contract itself. And if the parties cooperate, you can sort of roll it back up into the channel for a lot more throughput. There are some issues with this. It doesn't scale well, so you can't really put like dozens of Lightning DLCs within a single Lightning channel. If you had something like, what's it called now? There's new names for it, but the sig hash no input, whatever they call it now. That would allow you to scale this better, but it is possible. The sig hash no input lets you do things in a more scalable way. You can still do this. 4 or 5 probably is enough. So there's a lot of cool Oracle use cases. Discrete log contracts is actually a couple years old at this point, and it's starting to be built out and used. There's companies, Crypto Garage, SuredBits, and others that are using this. What's interesting is it predates most of this sort of DeFi stuff in Ethereum or in other coins, I guess. And I think it sort of shows that, like, yeah, see, this is a problem. With DeFi, a lot of, you see, I read about it because there's so many weird attacks and like kind of fun stuff with flash loans, and it's kind of fun. I mean, it's not like good, I guess, but it's interesting. And a lot of the attacks are Oracle-based attacks because a lot of the oracles they're not people, They're not signing at a specified time, and it's just sort of a program on this blockchain or on some computer which just sort of deterministically says, yeah, I'll report this price. And it's very susceptible to attack and to manipulation. So the ETH oracles generally are on-chain, and they compute values. And the idea of DLC is, no, move the oracle off-chain, and you don't compute anything. You're only verifying. The blockchain, anyway. The blockchain is verifying signatures and has no idea that there's even an oracle. And so this really brings up sort of oracle risks, where if the oracle knows about your contract, it's not really an oracle, right? It's a judge. Because if they see the contract they're sort of reporting a price for or reporting data to, they can make up whatever they want, and they can determine the outcome and then report the data. So you can sort of work backwards that way. However, if the oracle doesn't know your contract, then it's actually okay to have sort of a centralized human oracle. And I would argue it's better than okay. So centralized oracle. So in general, in Bitcoin, we don't want things to be centralized, right? We want it to all be decentralized. And it's not that the centralization inherently is bad, but it's usually a means to an end. So right, the reason you want miners to be decentralized is because you don't want one miner to control the system. They can do 51% attacks. They can deny your transactions and stuff. But you can imagine if there were centralized miner, but that miner had no idea what your transactions were, right? Your transactions were completely opaque, and all they could do was throw it in a block. Then it's sort of not as bad, right? And so similarly, we can think of oracles as they're probably going to be inherently centralized. So what we've seen, in traditional finance and traditional legal contracts, sometimes you'll say you're basing something off a market price, and you talk about a newspaper. And you say, okay, this contract is going to be about the price of oil, and it's determined by the back page of the Wall Street Journal on this day. And that's an interesting way to do it, because we're both looking at this newspaper. The newspaper just reports prices, right? And the newspaper doesn't know that we're basing our contract on it. And that's good, because the newspaper is really big. It's hard to influence the newspaper. And this makes sense. The more people that are relying on a single oracle, the harder it is to sort of manipulate the oracle. And so I feel like it naturally centralizes. But if it's centralized but oblivious, the way that newspaper is, it's okay. You can use this. You're not worried that the Wall Street Journal is going to misreport the price of oil so that it can make a contract go the wrong way. So yeah, we made, actually 2 years ago, we made a discrete log contract software demo and ran it to sort of do Bitcoin price, Bitcoin to dollar price oracle, so you could do these contracts. And today, Crypto Garage and SuredBits are implementing DLC, specifications, software implementations, exchanges. The biggest use case, I think, is going to be like US dollar Bitcoin short contracts. So for example, you think Bitcoin's going to go down, and you say, okay, I don't want to sell my Bitcoin because it's really cool, but I bet it's going to go down next month. I think it's going to go down, then maybe back up again. I don't want to sell my Bitcoin, right? I don't want to have to use an exchange and stuff, but I do think it'll go down for now. So I want to be short Bitcoin in terms of dollars without getting rid of my Bitcoin. And then someone else on the opposite side will say, oh, I bet Bitcoin is going to go up. It's going way, way higher. I want to leverage my Bitcoin. How can I do that? I already bought all the Bitcoin I can, but I want to have super volatile Bitcoin because I think it's going to go up. And you can do that, right? One person's short Bitcoin, one person's long, and you say, okay, what's the price of $1 in Bitcoin? And that determines who gets more or less. So it's DeFi on Bitcoin with no rule set changes. Yeah, so this is the last slide. I guess I have 1 minute left. So I think it's a really interesting thing. I'll talk a little bit about the history of this. Discrete log contracts, well, the name is more recent, but it actually, some of the ideas came before Lightning Network and sort of led into Lightning Network. And it was when Ethereum was first starting, and like 2014, I think, and I was talking to people at a conference, and they're like, oh, we're working on Ethereum, and so you can do these smart contracts. And I was sort of like, well, can't you do that on Bitcoin? They're like, no, it doesn't work on Bitcoin. We're making Ethereum. I'm like, I bet you can do it on Bitcoin. And so that sort of started me looking at these things, writing these things. It eventually, the technology eventually went into Lightning first, but it was sort of, I bet you can make these sort of conditional payments using Bitcoin, because it does have these scripts and it can do different signature verification and hash-based locks. So an old version of DLC used hash preimages the same way Lightning does with HTLCs instead of signatures. And Lightning as well is probably moving towards using signatures only instead of hash preimages because it's more private. So anyway, I hope everyone's interested in this and the development continues. I think it's a really cool technology that could pretty soon allow a lot of the cool futures contracts that people are using on centralized exchanges or on things like Ethereum to be working on Bitcoin itself with no real changes. It's just a matter of getting the network running. So thanks a lot.